Hello everyone, this is Bob Freeman. Today I'm going to be showing you how to create a little descriptive statistics analysis worksheet in Microsoft Excel. So, I hope you all are having a great day. It's a beautiful day outside. I'm outside right now, so I hope you're able to also be outside right now and enjoy the outdoors. It's a beautiful day. So, descriptive statistics are really useful if you're looking at historical data or any kind of numerical data in general, and you want to, like the name implies, look at some statistics about that data that can describe it. So, we can say test scores. So first you want to, open Microsoft Excel. That should be a given. Click New Workbook or whatever, blank workbook. Okay, and just give you an example. We'll do test scores. You click the top left square, A1, test scores. Okay, enter. Now let's type some hypothetical test scores. Okay, so let's say we had one student did a 75, one student did an 80, one student did a 95, one student had a 65, one student had a 70, one student had an 82, one student had an 83, another student had a 90, we'll do another 80, and let's say we had a student who got a 100. Oh no. 98. One student got a 98. And then let's say one student didn't show up and they got a 0. Okay? So these are our test scores. We have 11 of them. Now, looking at this, we could just read off each test score, but what if there was a way that we could, look at this to get an idea about how the class did as a whole? So what you're going to want to do is go to add-ins. You're going to want to go to add-ins if you haven't done this already. Data or statistics. I already have it installed, so I don't know if this will show up. I have it right here, data analysis. Okay. Well, you're going to want to do that. Go to add-ins. Sorry, I haven't. I've just had this on here forever, so it does not work if you click on add-ins. But if you go to the search bar and type in data you can click the add-ins there, and you just want to check the analysis ToolPak. Sorry about that, just haven't done that in a while. You only have to do that once. After you do that, you never have to do it again unless you get a new computer, download Microsoft Excel on that computer. You got to start over. But okay, we have this. This is what we want. Data analysis. So I'm going to click A2, which is our first test score. Hold down Control and Shift, and then press the down arrow. This will select all of our data. Now, we will click Data Analysis, and then this window will pop up, which gives us a lot of different options. We're going to click Descriptive Statistics, because that's what we are going to be doing right now. And then we are going to click OK. This will come up with another window. Now we're going to want our input range to be our data. So click A2, Control Shift down, and that selects our input range. This selects all of our data. Now our output range, you could put it on a new worksheet, but we're just going to do the output range. We're going to just click, we could just click C, click the box here, and then click C2. Click on Summary Statistics, because that's what we want. And then click OK. Double-click the line between the C and the D column. This will expand the C column to fit our labels. Okay. Now we can see some pretty interesting information about our test scores now. See how our class did. Our mean is our average. Okay. It's like a central point in the data. So we can see that on average, our class made a 74, which is not bad. It's a C. C's get degrees. Our standard error is 8. So this tells us how reliable our mean is. If we had a much larger sample size, like if we got the test scores of the entire grade and not just the test scores of the class, or if we got the test scores for that test every single year and we combined them, we could guess that our mean is going to fall somewhere between, 74 plus or minus 8. Our median is 80. The median is the test score that falls in the middle. Our mode is 80. Mode is the test score that is the most frequent. And as you can see, we have 80 here and we have 80 here. So it was the most common test score. We have our standard deviation. Now this measures the dispersion of our data. It tells us, how far away our other data points are likely to be away from the mean. So you see we have the mean of 74, and we have some that are, outside of 26, 74 minus 26. We can actually calculate that. Let's do we could do our first standard deviation, our second standard deviation, and our third standard deviation. We do plus, minus. So you could say in our first standard deviation, we'll fall somewhere between, press equals, use the arrow key to go over to the mean. Now, press F4. This will create an absolute reference, which means that when we copy this cell over, it will remain, the formula will remain selecting D4. It will not shift over when we copy it one to the right. It would normally shift over to E4, but if we press F4, it creates an absolute reference, meaning if we copy this cell over to H, it's not going to shift the reference over to E. It's going to remain in column D. So our mean plus our standard deviation will give us the upper bound of the first standard deviation. Now, if we copy this, Control C, right arrow, Control V. Now if we click this bar, we see, okay, D4 was an absolute reference, so it did not shift when we copied and pasted this over. However, E8 was not an absolute reference, so it did shift one to the right, and we shifted this one to the right. But we can just change E to D, and now we have the correct value. However, we do need to subtract the standard deviation from the mean to get our lower bound for the first standard deviation. All right, so as you can see, all of our data points actually fall in between this first standard deviation, with the exception of the 0. So we can already tell, this 0 is messing with our data a little bit. It's quite the outlier. It falls outside of our first standard deviation, and it's it's dragging down our mean quite a lot. And we can see that the median score is 80, and the mean score is 74. So if this center value is 80, but the average score is 74, this 0 is a problem. It's not an accurate reflection of how the students did during the test. Now we could continue to sum these out. We'll go ahead and make this an absolute reference, F4. Make this an absolute reference, F4. And we can Control C, Control V, Control V, Control C, Control V, Control V. There's a faster way to do that. I'll go ahead and show you real quick. So Control C, 1 to the left, Control down, 1 to the right. Now we'll do Control Shift up, Control V. There we go. But we need to subtract another standard deviation if we really wanted to figure this out, but this is not really useful because this goes, our data set's just not very good. We have a 0 in there. We have an outlier. Nothing's gonna fall. Nothing's gonna fall outside of this third standard deviation because, well, I guess you could say we just don't have a large enough sample size. That could be one. If we had, say, 1,000 test scores, this would be a much better data set to analyze. We could find out much more accurate information about our population if we looked at a sample of 1,000 versus a sample of 11. But what this does show us is that there is there's an issue with this outlier being here. We can actually visualize this we can create a histogram to see how this outlier is not very representative of the rest of the data set. And we can also just visually see that it is definitely an outlier if we create a histogram. So to create a histogram, we're going to need to create bins. Okay. Now these bins are intervals. We can select these and just drag it down until we have 100. Makes it a lot faster than typing them all out. So we're going to go back to Data Analysis in the top right corner. And we're going to select histogram this time. Press OK. For our input range, going to select our test scores, click A2, Control Shift down. For our bin range, we're going to select our bins. Click G10, Control Shift down, and let's make our output range I9. So press OK. And now we have a histogram right here ready to be made into a chart. Some histogram data. So select I9, Control Shift down, Control Shift right. We're going to select Insert in the ribbon above. We're going to click Recommended Charts, and we're going to select this one right here, the clustered column. So we can see that most of our values are falling between this range. All of them are falling between this range except for our 1, 0. This is definitely what we would call an outlier, okay? So, yeah, I'll go ahead and go over the other descriptive statistics here, just to give us a better idea of what we're looking at. And then I'm going to show you an example with real world data, much larger sample size, and just show you how this can really be used with real data in the real world, where you can find that data, etc. So we have our kurtosis right here. The kurtosis, if it's positive, if it's more than 0, it means that there's going to be a sharper peak with the data, and there's going to be more outliers. And you can see, we have a high kurtosis of 7 because we have this crazy outlier out here. If it's below 0, the kurtosis is below 0, it means that we're going to have a flatter peak and we're going to have less outliers. So let's say we had one score, say someone got a 5, 15, 25, 35, etc. in the test, we would have a very low kurtosis. We would not have, I guess we wouldn't have any peak, and we wouldn't have any outliers. Now skewness, we have a skewness that is a negative number. If the skew is negative, that means that our tail, it's on the left. So you can see, this tail, if we're can even call this a tail, it's definitely skewed to the left. If we had a positive skewness, if our skewness was above 0, our tail would be on the right. So that would look like if we had one student get a 100 and then another student got a 90 and then everyone else got like below 50% score, we would have a positive skewness. Now our range is just going to be our maximum value minus our minimum value. our highest score was a 98, and our lowest score was a 0. And then our sum is just going to be all of these test scores added together. And our count is going to be the number of different test scores that we have. So you might think, oh, well, this is silly. There's, more, when am I ever going to be, I'm not a teacher. I'm not going to be using this. Maybe you are a teacher and you will use this. I know a lot of teachers that do this with their students' grades, but, what's a data set in the real world you could actually use this kind of a descriptive statistics analysis for? Well, I'll show you real quick. We can do this with stock market returns, and we can compare them to an individual stock's returns. So let's go to historical data. VOO. VOO is everyone likes SPY. I feel like everyone knows what SPY is. So SPY is the S&P 500 index. It's just a large index fund that tracks 500 large companies in the United States stock market. Oh, let me turn on my hotspot. I'm outside right now. Awesome. Connected, secured. So, historical data, SPY. Used to be available on Yahoo Finance, but you have to pay for that now. They do have this on the NASDAQ website. So, maximum download historical data. We can download this. So this is for the S&P 500. This is the closing price for the day for the S&P 500, the volume of the index, the amount of contracts that have been traded. We don't really need this. We'll just go ahead and delete it. The open, what price did it open at? And the high and the low, we don't really need that either. That's the highest price of the day and the lowest price of that day. So we'll go ahead and delete that. So if we want to get the returns of this stock market index for each day, we will just subtract the closing price equals parentheses, subtract the price that it was at the end of the day. We'll subtract the price it was at the beginning of the day from the price that it was at the end of the day, and then we will divide it by the price that it was at the beginning of the day. As we can see, on May 9th, 2025, the stock market started at $566.48, and the day ended, it was at $564.34. So it went down. It had a return of 0.378%. So we're going to select this cell. We're going to go up here, number format. We're going to select percentage. And people love to double click this, so I'm just going to show you it this way because people love this. I prefer to do it a different way, but a lot of people just like to double click this little handle, and it will automatically fill out all the cells. See, all 2,517 of them. So it's a lot of data. How the heck are we supposed to look at this? We can't do, like, are we going to count these up? Are we going to, like, write this out and figure out what the average is, or we can add all of these together and divide them by 2,500 something. No, of course not. So thankfully, we have Microsoft Excel. We can go to Data Analysis, Descriptive Statistics, OK, Input Range. We can put our returns for each day. Control-Shift down. We can make our output range. Let's do F2. Summary statistics, remember to click that. And then press OK. What did I do wrong? Oh, I see. Make sure that this is clear before you select your reference cell, F2. Okay, so a lot of this data is going to be a lot more useful if you change the formatting to percentage, because we're working in percentage terms here. Looking at these decimals is not going to be, you're not going to just like intuitively understand this, so you should definitely format this to be percentages, just like you have the returns data. Do the same thing with the standard deviation. And we can also do that with range, minimum, and maximum. So we can see that on average, if you were to buy the S&P 500 at the beginning of the day and sell at the end of the day, you'd get 0.02%. We have a standard error of 0.02%. So, I mean, plus or minus 0.02%, it probably not going to make anything, especially after brokerage fees are concerned, if you just buy at the beginning, sell at the end every single day. Our median, 0.05%. Standard deviation, 0.08%. So this is actually useful here, because what we can do is we can look at what would be an unusual move in the stock market. We can 1, 2, 3. So first, second, and third standard deviations, plus, minus. So we'll go ahead and get our first standard deviation is going to be our mean, F4 to make it an absolute reference, plus our standard deviation, make that an absolute reference. Control C, Control V. Now this is going to be a minus. So we could say, on any given day, probably going to be somewhere around 88% returns and minus 0.84% returns. So you can expand this to increase your confidence level of how much it's likely to move. So we could say, it's probably going to do this, but often it's probably, or often it may fall out of that. That probably happen, it happens sometimes. So we can increase our confidence of this range by looking at our second standard deviation. F4, Control C, Control V. I'm just going to go ahead and fill these out because just give you an idea. It'd be easier to fill these out first and then explain it. But you see, I'm just subtracting another standard deviation from the mean for the lower bound, just subtracting another standard deviation from the mean. What the heck? Okay. So we could say with about 68% confidence that the stock market's going to fall between these returns each day. We could say with I believe it's 95% confidence, stock market's going to fall between these returns each day. And then we could say with a 99% confidence, stock market's going to fall between these returns each day. So if you see a stock market move that's more than like 2.61% or negative 2.57%, you can pretty confidently say it's an unusual move. That doesn't happen very often. Very rarely. 99% of the time this does not happen. So you could say, okay, what the heck's going on if it's moving outside of this? If you see the stock market move like 0.5% one day, it's just noise. It doesn't really mean anything. It's, usually does something like that. So we can also create a histogram, but when we make our bins this time, we need to keep in mind that we're working in percentage terms. So a percentage we could do, and we also need to keep in mind that there's a lot of negative values here. So we'll go ahead and start with like the negative values. Do minus 0.0 0.005, or I guess we gotta start pretty 0.0, so 0.03, and then we'll do minus 0.025. Let's create a lot of bins for this one. Drag this down until we have, there we go. All right, so these are our bins for our histogram, so we can visualize this data a little bit further. We will click Data Analysis, Histogram, OK, Input Range. We are selecting all of the returns, so click D2, Control-Shift down. Bin range, these are our bins. We're going to click J10. Make sure that this is cleared out, by the way, before you select, or it will return an error. J10, Control-Shift down. Output range, let's do L10. So we'll press O. Like I said, make sure that this is cleared out before you select your new reference. L10. Okay, so this is our histogram data. We can select this, insert, recommended charts, clustered column, okay. Now we have a nice little histogram here. Okay. We can see that we have outliers on either side. We see we have a pretty sharp peak. Okay. This is also evident with our kurtosis. Before making this histogram, we could see that, okay, this is going to have a sharp peak with a lot of outliers because kurtosis is really freaking high. Now, when we look at our skew, we see that it's a little bit more than 0. So our tail is on the right. But we do have, we have most of these fall on on the left-hand side. We have these crazy look at all these data points on the left-hand side. But it's a lot, like these are a lot less common than these. So it's not like a huge, not really a lot less. I mean, sorry, our skewness is not super high, but it is there. It's just something to keep in mind that when you invest in the S&P 500, there's some tail risk. Okay. Now, our range, this is going to be our maximum minus our minimum. We can see that the lowest daily decrease since, how old is this data? Since 2015 is minus 5.66%, and our greatest daily increase was 11.18%. Sum doesn't really matter. We can see that the number of data points we have is 2,516. Now, this is great for looking at the entire stock market and all, but let's say you wanted to look at an individual stock and compare it to the stock market's risk profile. So, we could just do exactly what we did here, except instead of S&P 500, let's do Apple, because everyone knows what Apple is. You're probably watching this on your Apple device right now, because everyone has a freaking iPhone. So we're going to download we're going to maximum download historical data for Apple, and we're going to do the exact same thing. I'm going to do it really fast because my computer is going to die, but I can definitely get this done before my computer dies. So feel free to follow along or not. I always forget which one it's going to be. Yeah, it's that one. This is how I usually do it, because I don't like to... Of course I mess it up. I don't usually like to use my mouse unless I have to, especially I'm on a laptop right now. I don't have a mouse. Returns. Percentage. Data, descriptive statistics. Okay, input range. Output range, keep it the same. Change the formatting for these statistics. We can do our standard deviation. All right. I'm plugging in the wrong stuff here. This is not minus G4. This is minus G8. Okay. Okay. Awesome. So we also have to create our histogram. We can, let's see. Let's do the same bins so it's easier to compare to the stock market. These are going to be our bins. Now, data analysis, histogram, okay, input range, select our data, bin range, select our bins, output range, yeah, let's just do L10 again. Okay, so we have our data. For the histogram, insert recommended charts, we'll do a clustered column. Okay, so let's put all of this information into the same workbook so we can compare the stock market to Apple stock when it comes to its daily returns. So specify that this is Apple, specify that this is Apple. Roll S&P 500. S&P 500. So we're going to copy this table, put it here, copy this table, we will put it here, let's put our let's go ahead and bring this in here too. Oh, okay. This would be a good thing to show you all. So because this is referencing, there we go. Since this is referencing a ton of different stuff, and I honestly did not format this as well as I should have, we can, what we can do, if we just want the values, Control C to copy this, and then we'll right click, paste special, and then we're only going to do values. Okay. And then we just reformat this to be percentages. Okay. Now, what would actually be even better, you can right click, paste special, values and formatting, so you don't have to reformat it. And then finally, we will put our histograms in here, side by side. So, awesome, beautiful. I zoom out a little bit. All right, so we can see that Apple, on average, has a higher return every day. You can see, let me move this over here, so we can expand these columns. Apple, on average, has a higher return every day. It has a higher mean return every day, higher median return every day. But we can also see that its returns are further dispersed than the S&P 500 returns. We can see this in our standard deviation tables right here, which show us that although it has a higher positive return on average each day, it's also more likely to give you a larger negative return as well. You're much more likely to get a negative 1.25% move in Apple each day than you are to get a negative 1.25% return in the S&P 500. Likewise, much more likely to get a negative 3% move in Apple than you would to get a negative 3% in the S&P 500. But you are much more likely to get a positive 3% return in Apple than you are to get a positive 3% return in the S&P 500. So this just shows us, okay, if you want to make higher returns, you got to take more risk. That's a big part of this game when it comes to the stock market. Higher risk, higher returns. All right, I just got the battery saver mode is on. We got to move quickly here. We see that S&P 500 has a higher kurtosis than Apple, which means that it has a sharper peak and it has more outliers. We can see this when we look at the histogram. Sharper peak, more outliers. Apple, not as sharp of a peak, less outliers. When we look at our skewness, we see that they are actually about the same. Okay, so both of them have a tail that's slightly more on the right-hand side. And then we can see with our range, Apple has a much larger range when it comes to its minimum and its maximum return. Apple's best day was 15.64%. Its worst day was negative 7.65%. With the S&P 500, its best day was 11.18%, and its worst day was negative 5.66%. As we can see, there's more risk with Apple, more potential returns. With S&P 500, there's less risk than Apple, but there's also less potential returns. All right. By looking at these histograms side by side, we can see that Apple, you are more likely to get these larger returns, but you're also more likely to get these larger risks, okay? With S&P 500, you can see you're less likely to get these larger returns, but you're also less likely to get these larger risks. So, I hope that this was informative for you. I hope this showed you a little bit about what you could do with Microsoft Excel and analyzing numerical data. You don't have to do this only with stock market returns. You can also do this with survey data. You could say, how much did you like the party that I threw last week on a scale of 1 to 10? And give that survey out to everyone who attended your party. And you can put that data together and do this exact same thing. See how much people liked your party on average. You can see how many people hated your party. You could see if everyone was kind of in the same boat when it came to liking your party. If everyone liked your party just about as much as the other person, or if, people felt really different kinds of ways about your party. You could apply this to test scores in a classroom. You could apply this to anything you could put a number on. You could put it on, height data in different countries and compare the average height of human beings in one country to another. You could do it with weight. So many things you can do this with. I really enjoy doing this with any data I can get my hands on. I highly encourage you go out and do the same. I have a lot of fun with this. It's a great freaking time. I hope you have as much fun with this as I do and learn a lot. The best way to learn is by doing and by looking at things for yourself, not taking what other people say at face value. If anyone has ever told you that Bob Freeman is a scam, you need to stop talking to that person, because you do not need that kind of negativity in your life. I hope that's very clear. It's what the numbers are showing. So, have a great rest of your day. I hope you do this on your own. If you do this on your own, please let me know what data you did it with and what you found out, and if you found this of value. If you have any video suggestions, please let me know. Please like and subscribe. Leave a comment. All the wonderful things. And stay blessed. Goodbye.